Right?
Yeah.
Okay, so I have a substance here for you guys in this big gigantic container called a Dewar flask.
Lean.
What is
You
it?
spilled some. Dewar flask.
Nitrogen.
It's dry ice.
No, this is not dry ice. Dry ice is a solid.
Liquid
This is
nitrogen.
liquid nitrogen.
That's wrong.
Yeah.
Nitrogen, N2.
It's evaporating.
N2, what type of intermolecular forces are going to hold N2 molecules together?
Hydrogen. Dipole.
N2?
Nitrogen.
We need NH to have a hydrogen bond.
Come on now.
London dispersion, why?
Because it's a non-polar bond.
Because it's a nonpolar bond. It's two nitrogens bonded to each other, same electronegativity. Okay, the show's over here, buddy. Same electronegativity, nonpolar bond. It's got to be a nonpolar molecule. So, what holds together nonpolar molecules? What holds together nonpolar molecules?
London dispersion.
London dispersion.
You right? Yeah.
Okay, now that means that in order to get those molecules to stick together, to turn into a liquid, they have to be going extremely slowly. We have to cool them way down. Liquid nitrogen is at a temperature of minus 196 degrees Celsius. So cold that when I pour it on this table is 200 degrees warmer than the nitrogen. It boils instantly. And it actually creates a little cushion that liquid drop rides on. Okay?
What if you touch it?
What if you touch it? It can give you frostbite very, very quickly. Actually, when I poured it the first time, some stuck to this glove and actually just about gave me frostbite, so these gloves are useless. I'm getting rid of them. All right? Now, I'm going to do something very dangerous.
Yeah.
You're pour-
Your hat? Oh.
Oh, well.
What?
No, it's going to evaporate. It's
No
gonna
balls.
evaporate Because your hand is too hot.
Same thing happens. My hand is so much hotter than this nitrogen, it boils instantly, and that little cushion of boiled off nitrogen protects my hand from the liquid actually touching it. Okay, now if I were to cut my hand, I would get frostbite real, real quick. Okay, I can actually stick my finger in here.
I do it.
No. If I hold my finger in here, it's going to get frostbite, okay, because my finger will cool down, the nitrogen won't boil as much, it'll touch my finger and give me frostbite. Okay, I'm going to pour it into this little weird shaped cone that I've made over here. It's made out of metal. And what you can see coming off the top is what?
Bubbles.
Vapor.
Evaporate.
You can't actually see nitrogen when it's in the gas phase, right? There's nitrogen in the room around us right now and you can't see it. What is this stuff?
Water. Liquid.
It is water. It's moisture from the air that we can't see either.
Vapor.
But when that water vapor hits this super cold nitrogen gas that's coming off of here, those water molecules, which are held together by
London dispersion. No, dipole.
water molecules, look at it up there.
Hydrogen.
H2O.
Hydrogen.
Hydrogen bonding. We've got an OH bond. So they're held together by hydrogen bonds. So when they hit that cold nitrogen, they start to stick together, making these little droplets we see as fog.
Vape.
My breath has more moisture in it, so when I breathe it over that cold nitrogen gas, we get an even bigger cloud. Now, if you look at the side of this, cameraman, bring it in.
Oh, I got you.
Pay attention, man. We can actually see this weird little, like, up and down front here. It looks like the outside of this funnel is wet. It is, but the outside of the funnel is not wet because of water. This is so cold, water is freezing instantly. You see the frost on the outside? The moisture in the air is actually turning into solid because those hydrogen bonds are so strong. Okay, what is the liquid? Well, the liquid I can show you. It's not actually nitrogen. There's no hole in this funnel. It's not really a funnel, it's a cone. There's no hole in this. But if I bring this magnet close, come on, cameraman. You see that? Woo! Woo! That's cold. Did you see this liquid stick to the magnet? You ever seen a liquid stick to a magnet?
Never.
No. No. This is a magnetic liquid. It's actually oxygen. I'm creating liquid oxygen. How the heck can I create liquid oxygen?
God.
cooling it.
Well, what holds oxygen molecules together? What are the intermolecular forces between oxygen molecules?
Dipole. Wait,
Oh, man.
no.
You guys got an exam coming up on Monday. You got to be better than that. O2! London dispersion. It's the same two elements. It's a nonpolar bond. It's a nonpolar molecule. I'm going to pour a little bit more in here so I can create even more liquid oxygen. And I'm going to pour some into this cup to cool down the test tube that's in there so that my oxygen doesn't boil away right away. Now, both nitrogen and oxygen have London dispersion forces between them. But whose London dispersion forces are stronger?
Nitrogen. Well, no, oxygen, because it has a higher,
Oxygen, 'cause that's
higher. No, the electronegativity is higher. Yeah.
Wait.
Remember the lab that we did. What is it that determines the strength of a particular type of intermolecular force? What about the structure? The mass, the size. It's truly the size, right? Oxygen, being more massive than nitrogen, has stronger London dispersion forces, so it actually turns into a liquid at about minus 170 Celsius, whereas nitrogen's minus 196. So in this test tube, we've actually got some liquid oxygen. We've got liquid nitrogen in there as well, but we have liquid oxygen.
What if you drink the oxygen?
If I drink the oxygen, I'm going to burn the inside of my throat. And it's going to be bad, okay? Now I'm going to show you that that is in fact liquid oxygen because I'm going to take this little wooden splint. I'm going to light it on fire.
Oh, it's gonna light up. Oh, let me go.
And when I put it in there, you see how much stronger the flame becomes? Why? Because there's oxygen in there. More oxygen in here than there was in the air. It's almost pure oxygen. If I dump this out and I pour nitrogen in there, it goes out. Because nitrogen does not support combustion. Oxygen does. So that was actually liquid oxygen that was coming off of here. Okay, next I'm going to take a substance called methane. Methane is CH4. CH4 is a tetrahedral geometry. Is that polar or nonpolar? Tetrahedral's nonpolar. So methane molecules that are tetrahedral, nonpolar molecules are held together by what intermolecular force?
Dipole.
London.
London dispersion.
London dispersion, okay? Are the London dispersion forces of methane stronger or weaker than oxygen and nitrogen?
Stronger.
Are the London dispersion forces of CH4, methane, stronger or weaker than oxygen or nitrogen?
Stronger.
Wait, what's the
Well.
question again?
Wow, for the third time, are the London dispersion forces between methane molecules stronger or weaker than the London dispersion forces between nitrogen molecules?
Methane.
Methane, CH4. Well,
Nitrogen.
judging by the sound that there is in this test tube, they must be stronger because I am cooling down the methane to the liquid nitrogen temperature and it is turning to a liquid as well. Now that's because of the size of the molecule. We've got 5 atoms in CH4. That makes a bigger molecule, which means it's going to have stronger intermolecular forces, stronger London dispersion. Okay, even though it has a lower mass, it's actually the size of the molecule, the surface area of the molecule, that determines how strong those London dispersion forces is. Okay, so what I want to do is collect a nice little sample of this methane, and I want to prove to you that it is methane. What do we know about methane?
It's flammable.
It's flammable, yes.
Yo.
So if there is actually methane in this test tube, it should be able to burn,
Yeah.
right? Now, I would like somebody to turn the lights off so we can see in the dark whether in fact we have...
When do you want me to turn it off?
right now is fine. Okay. So, I'm going to take this little torch. Okay, you see the flame?
Yep.
Now the methane, the little liquid methane that's in here, is boiling because it's being warmed up by the warm room. You don't see any flame on the inside of the tube. Why not?
Because
There's no oxygen. It's just pure methane in this tube. Until that methane reaches the air and can get some oxygen, we don't get that combustion. All right? So, I'd like to do something if you all could back up a little bit.
He's gonna flip it.
I'm going to pour it out. Ready?
Watch out. Boy, wait, hold on. Yeah.
Get all your Snapchats ready to go.
Oh, what is this? Wait, hold on.
Ready?
Wait.
Not you, you're cameraman.
I'm both. Yeah, I'm both. Yeah.
By the time you get your
Go on,
Snapchat
you
ready.
good.
Okay, ready?
Whoa, goat.
Good.
So, the methane has such a low boiling point,
The
when it
twins.
hits the floor, it creates that little cushion of methane, just like the nitrogen did.
Oh, I didn't get
right?
it with this.
But, as it rides on that little cushion, it's constantly giving off flammable gas, and so we're seeing those little drops. What are you doing?
I didn't get it, so I had to tell it. So
You took it with that, but not mine?
I showed it on this though. It's
You
okay.
have to do it again, Mr. Wolf. Yeah, you gotta do it again.
Alright, well, as that is,
A lot more.
as we are making that methane, can I do a lot more? I could, but I don't want to start the school on fire because I enjoy being gainfully employed. I'm going to take some of these cheese balls,
Hey.
which is a new batch, freshly opened,
Oh gosh.
and I'm going to cool them down.
You're gonna have 3
Freezy cheese balls.
Whipping it.
That's going to cool them down
balls.
quite a bit. What I really want to do with these cheese balls, can you turn the lights back on, please, Ryan? I'm going to pour off the nitrogen. I don't want that extra liquid in there. I just want the cold cheese balls.
Eat it.
Ready?
Put up. They're like really hot.
Are you gonna eat?
Oh,
Yeah. Wait. Yeah. I do O's.
Ghost. Woo! I'm going to freeze my fillings.
Wait. Do that again. That was pretty good.
Ready?
All right.
babe.
Yeah.
Woo!
Wait, Mr. Wolf.
Again, that
Tried them.
moisture in my breath as the little bit of nitrogen, cold nitrogen, that's trapped in those cheese balls. As I crunch on them, that releases that cold nitrogen, which condenses the moisture that's in my breath, and then I'm
Nice.
breathing out those little condensed droplets of fog.
Can I have
Okay? One last thing I can do here.
You gonna freeze a tennis ball?
Let's see what we can do to a tennis
Wait,
ball.
would the tennis ball shatter?
Can I have some cheese balls?
This is a real tennis ball. It's not a trick tennis ball.
No, it's fake.
Oh God.
I think Justin really wants to ball.
Wait, would the tennis ball shatter?
Well, we're gonna find out.
Boy.
Okay, now this tennis ball has a lot more mass, so it's really boiling that nitrogen off quite a bit. Takes a lot of nitrogen. If you guys want to,
Wait,
one
are
or
we gonna have
one
to?
or two.
Are we gonna have to do it?
Don't stick 8 in your mouth.
Cameraman,
Cameraman, pay attention.
Oh
Are we
god.
gonna have to like?
Still on the job.
Wait.
Thank you.
Hey, Jay, you want?
Wait.
Ready?
Okay, let's see what the nitrogen. Let's see what the nitrogen did to my tennis ball.
Wait. Oh my god.
It's like a baseball.
It's like frozen.
Ooh.
Boy.
What the hell?
Frozen's out. So that rubber that was on the inside making the tennis ball bouncy originally, at the temperatures of that liquid nitrogen, it's no longer flexible,
Wow.
right? So we don't get that bouncy effect, and I can actually crack that rubber on the inside
They're better
just
frozen.
by
You want to do
Stop
another one?
All right, let's do our next batch of liquid methane. All right, lights.
Camera.
Action. And everybody back up.
Turn off the lights. I'm looking. Alright, I have to get it now with this.
Yeah, come on down. Let's see if it's better.
Ready?
This is gonna be raw. Oh, that's raw.
Oh!
Oh.
Oh!
smooth.
Well, you got big tits.
Got him. Check it.
I thought the
right, that's
the
it.
cabinet was gonna.
That's it.
It's still up.
It did catch on fire a little bit, actually. Well done, sir.